Hey there, Mr. Sutton here, bringing you the Algebra 2 6-5 Part 2 homework solutions on properties of logarithms. In this one, we will work on condensing logarithms. For this first problem, we're trying to combine log base 3 of 6 and log base 3 of 2. Since we are adding these logarithms and it's the same base, we can merge it into one big logarithm by multiplying their inputs. So this will be log base 3 of 6 times 2, or log base 3 of 12. And just double checking, 12 is not a power of 3, so we can leave this the way it is. To condense these logarithms, since we're subtracting them, we need to divide their inputs. So this is going to be ln of 12 over 4, which I can simplify to ln of 3. To condense this log, we have to take care of this 2 out in front. We're going to use the pop-in rule and move this multiplier in as an exponent on the input of 6. And then 6 squared is just 36. Double checking, 36, although it's divisible by 3, it's not actually a power of 3. So we're going to leave this the way it is. To condense these logarithms, we have to start by first using the pop-in rule to take care of these coefficients. So this 6 comes in to give us ln of x to the 6th. This 4 goes in to give us ln of y to the 4th, and we're still adding those logarithms, but now we can take care of this addition by turning this into multiplication of the inputs. So this is all going to be ln of x to the 6th, y to the 4th. To merge these logarithms, let's first start by moving the 6 and the 4 in as exponents. So this first term I can write as ln of 2 to the 6th. And then we're subtracting ln of y to the 4th using our pop-in rule there. Now, since I am subtracting these logs, I can actually divide them as inputs in one big logarithm. So this is going to be ln of, and I can turn this into 64 now, and then we have that divided by y to the 4th. To condense these logs, let's begin by using our pop-in rule to take care of those coefficients. So we've got ln of 2 to the 5th, ln of x to the 7th, and we're still adding that, and plus ln of y to the 4th. Now, since I'm adding these logs, I can move them in together by multiplying their inputs. So we're going to have ln of, let's make this 32, x to the 7th, and y to the 4th. For this problem, we're told that the intensity of the sound of a television commercial is 10 times greater than the intensity of the television program it follows. I wonder if that's actually true. It would make sense. We want to know by how many decibels does the loudness increase. So they gave us this loudness formula here, where you take the intensity and plug it in. And the idea here is that we're just dividing the intensity by the intensity of some really small sound here that's barely audible. So how do I actually do this problem with this formula? Well, if we're talking about a loudness that's 10 times as intense, we're basically saying we have L of 10i instead of L of I. But now if I want to know by how many decibels does the loudness increase, I have to take the difference of those two loudnesses. So we have L of 10i minus L of I. And if I actually write that out, plugging 10i and I into this formula, I've got 10 log of 10i over I0 minus 10 log of I over I0. Now I can condense this a little bit, and maybe if I do that I'll be able to actually figure out a number for this. I can start by factoring out these 10s. So that leaves me with 10 parentheses, and then we have these two logs that are being subtracted in the same parentheses together. Now if I'm subtracting these logs, that means that I can divide their inputs. So I can write this in here as log of 10i over I0 divided by I over I0. But if I'm dividing by a fraction, I can actually just multiply by the reciprocal. So I'm going to skip a step here and call this log of 10i over I0 times reciprocal of this, I0 over I. And now at this point I can simplify a little bit. These I0s cancel out. I sub zeros are gone. The i's cancel out as well. So this is just 10 times the log of 10. And before I go for my calculator, this is log base 10, and we're plugging a power of 10 into it. 10 to the 1 is 10, so this is really just 10 times 1, which is just 10. And that unit's going to be in decibels.